Okay, this is a video on what is called the Poisson Distribution. Okay, so the Poisson Distribution is um, has certain characteristics. One, the random variable x represents the number of times something occurs over an interval, usually of time. Okay, so this could be like the number of times a student enters the room in an hour, the number of times a taxi cab passes a certain point in 30 minutes, the number of times that, like, I don't know, a a player hits a baseball during a game. So this could be a Poisson distribution. One of the things is that these occurrences have to happen at random, or at least seem to happen at random. You can't readily predict that they're happening. The occurrences must be independent. So one occurrence cannot cause the next. And they have to be uniformly distributed over the interval. So you can't have a whole bunched up at the beginning of the interval, or bunched up at the end, or bunched up over the middle. They have to be able to happen at any time during the interval with the same probability. All right, so there is a formula for this, which is a little bit complex, but we're going to take a look at that now. Okay, so the Poisson distribution formula is that the probability of x occurring, or the probability that something occurs x times over the interval, is this lambda. So it's kind of like an upside down y. Lambda to the x times e to the negative lambda over x factorial. All right, so that seems kind of like really mathy and complex. All right, so what is lambda? Lambda is the mean, or the expected number of times this event will occur over an interval. So the mean number of occurrences over the interval. So we will know that, like, on average, 3 trains come to the station in an hour, or on average, he gets 3 hits per ball game, or on average, she scores 2 goals per soccer game. So we will know the average of the occurrence. That's the parameter lambda. X is what we want to know. E is a constant, and the rest of it kind of works out nicely. Okay, so we have an example here. Okay, so in our example, over the past 100 years, there have been 530 hurricanes in the Atlantic Ocean. Okay, so this means if I take 530 530, and divide that by 100 years, we're averaging about 5.3 hurricanes per year. All right, so this is my lambda. Lambda is 5.3. Okay, so let's say I want to know the probability of finding we're going to have 4 hurricanes this year. So the probability of having 4 hurricanes is going to be lambda, which is 5.3 to the power of 4 hurricanes, times e to the negative lambda, so that's going to be negative 5.3 over 4 factorial. And if you actually pop that into a calculator, you're going to get 0.164. So the probability of having 4 hurricanes this year, given that there were 530 in the past 100 years, is 16.4%, which is relatively high, I mean, for a particular number. All right, so this seems like an overly complicated problem. So, of course, there has to be a way to do this with your little TI-84 calculator, and I'm going to take a look at that now. All right, so let's do this exact same problem using the calculator. So again, we're going to hit second vars, and we want the Poisson distribution. That's going to drive down a little bit here. And under binomial Poisson, there's Poisson PDF and Poisson CDF. We want the Poisson PDF. Okay, lambda was 5.3. My x value is 4. I hit paste, I hit enter, and voila, 16.4%, just like we got when we did it with the formula. So this is the quick way through the problem. That's about it. So there's your quick notes on the Poisson distribution.